Chapter 2 Fundamental Data Types 2.1 Integers. In both Java and C++, integers can be either short, long, or just themselves. For Java, shorts are 16 bits, integers are 32 bits, and longs are 64 bits. C++ allows longs, shorts, and integers to all be the same size. Long and shorts are modifiers for the integer data types. It is legal to declare a value as both short and integer, or to use the modifiers by themselves. For example, short int x declares x as a small integer. Long y declares y as a long integer. Integers can be either signed or unsigned. For unsigned, they can only hold quantities that are greater than or equal to 0, while signed uses the same number of bits in the negative and positive direction. For example, a 60-bit unsigned integer can be between 0 and 65,535, while a signed 16-bit integer can be between negative 32,768 and 32,767. For division and modulo operations for negative integers, the C++ language leaves the meaning of them undefined. The language implementers can be free to use the natural instruction provided by the underlying hardware. For example, negative 23 divided by 4 can be either negative 5 or negative 6. In another example, 21 modulo negative 5 can either be a 1 or negative 1. The modifiers signed and unsigned are orthogonal to long and short, permitting a large combination of them. C++ does not recognize the byte data type. It uses signed character to represent byte-sized quantities. 2.1.1 Characters. In C++, characters are typically only an 8-bit quantity. Both C++ and Java say it is legal to perform arithmetic on characters. The Java Unicode escape format is not recognized by C++, but ASCII is allowed in C++. Characters can be signed or unsigned. 2.1.2 Booleans. The Boolean data type is annotated as bool in C++. Previously, integer values was used to represent Boolean quantities. A non-zero arithmetic quantity was interpreted as true, while zero value was false. The bool data type is still considered to be an explicit integer data type, but it cannot be signed or unsigned. Arithmetic operations can be applied to bool values, which results in the bool value being converted into an integer, 0 for false, 1 for true. Then integers can be assigned to bool value variables as well. A non-zero value is converted to 1. Pointer values can be used as booleans. The value is considered false if it's null and true otherwise. 2.2 Floating point values. Floating point quantities can be broken into 3 ranges: float, double, and double long. Doubles most commonly used in floating point literals are implicitly defined as double precision. C++ is more flexible with conversions than Java. For example, assigning a floating point value to an integer variable is illegal in Java without a cast, but acceptable in C++. If constructors are used as conversion operators, or explicit conversion operators are present, the programmer should be careful as those operators can implicitly invoke conversions without warning. The standard mathematical library routine will never throw an exception and will only halt executions, unless the hardware throws a hardware fault. Java supports 3 floating point values that are not numbers: none, negative infinity, and positive infinity. These numbers can be permitted in some C++ platforms, but are not required to do so. 2.4 The void type. The data type void is used to represent a method or function that does not yield a result. The type can also be used as a pointer type, to describe a universal pointer that can hold a pointer to any type of value.